Determine the internal force for each member. Assume AE is constant. First of all, we have to check value for externally indeterminate or internally indeterminate, which is formula for EI is R minus 3 II M plus R minus 2J. For our truss, the reaction pin 1 Y and X and roller just Y. So reaction R is 3, number of member M 1 2 3 4 5 6 7 8, number of joint 1 2 3 4 5. So check value for EI, externally indeterminate, R minus 3 equal to 3 minus 3. Therefore, externally okay. Then we check for internally indeterminate, M plus R minus 2J. Our M is 8, reaction is 3 minus 2J, joint is 5. Then we have 1. Therefore, we have 1 redundant internal. To solve our problem, we have to remove one of the members in this truss. But you have to think, although it's one redundant, we cannot take out any member as we wish. We have to think which one the most suitable. For our case, we take out members BD. Also for this case, we can take out members EC if you wish for that. But please don't take out other than that, because you can think if you take out members AE, it's gonna look very weird for your truss. Similar if you take EB out. So once we take one of the members out from our truss, we call that as real case, where we take out members BD. So first of all, you need to calculate reaction for overall structure. For pin, we have Y and X reaction. Also, we have for roller Y reaction. We take summation, moment at A equal to 0, positive clockwise. Our external force 12 kN times by 3 meter. We know this height is 3 meter. Minus reaction at C. We call it CY. So this one is CY times by 6. This distance is 3 meter, 3 meter. So 6 equal to 0. Then we have our CY. CY equal to 6 kilonewton. Then we calculate our reaction AX and AY. Simply we know our AX equal to 12 kilonewton, but to the left, since this one to the right. And for AY, 6 kilonewton going down. Then you have to change this direction, or you just remember that. So direction for this one to the left, AY going down. Once again, for real case, please do remember we already removed member BD. Now let's start to analyze internal forces in each members we do have for real case. To do this, we're going to do ratio method, or in Malay word we call it kaedah perkali. We cannot simply analyze at any node do we wish. You have to think which joint most suitable. For member C, we know reaction CY, but we cannot find forces in members BC, CE, and CB because we have 3 members. Similarly, for joint B, we have 1, 2, 3. So we cannot start with that. The way we can do, we start at joint A because we just have 2 members. Now we're going to calculate internal forces in each member. In this case, at joint C, we have value for reaction CY. However, we don't have X reaction, X forces. Therefore, we cannot find forces yet at joint C. Similarly, at joint B, we cannot find it. At joint A, we have X forces and Y forces. Therefore, we can distribute that into these 2 members, member AB and AE. Now let's start at joint A. We know we have AY and AX. For member AE, we're gonna have Y forces. Therefore, all the Y forces going into member AE. At joint A, the Y forces going down with magnitude of 6 kN. Therefore, in equilibrium, this going up with 6 kN. So this one is 6 kN due to AY is 6 kN. Then we know the slope for AE is, this one is 3 meter, this one is 3 meter, 3, 3. Then we need to find value here. So we're going to use ratio method. We know this 3, 3 due to this distance, 3 meter into 3 meter. We know our Y force is 6 and we don't know X force. For the ratio method, we know this is 6 kN and incline with value of 3 equal to X this X proportion to 3. So this is 3. So find your X. Your X is 3 divide 3 times 6 equal to 6 kilonewton. Therefore, here is 6 kilonewton. With the same members, we have to find at the other end on joint E side. Since this going up with 6 kilonewton, so that means on the other side is going down with 6 kilonewton. Similarly, this one to the right with 6 kilonewton, to the left with 6 kilonewton. Now look at member AE. We're going to find magnitude of force for AE. So this is AE. So we're using trigonometry to find that. The magnitude for that, 6 power of 2 plus 6 power of 2 square root equal to 8.49 kilonewton. 8.49 4 kilonewton. How to know in that member tension or compression? We take, for example, member AE. We know the force direction at joint A going that way, and at joint E going that way. So this one is tension force. For tension is positive. So this one is tension. We done for member AE. Next, we can analyze member AB. We know our AX to the left is 12 kilonewton, to the right with 6 kilonewton. That means balance in member AB is 12 minus 6. So 6 kilonewton to the right. Near to B is arrow other way around, so to the left. Check this symbol, that direction. That means this one is tension with 6 kilonewton. Now let's look at joint B. At joint B, the force we have only in X direction from member AB with 6 kilonewton to the right. That means this 6 kilonewton to the left. Since we only have X force, that means no force in member EB. This one 6 kilonewton to the right. The next side to joint C, automatically to the left with 6 kilonewton. That means this value is 6 kilonewton. Check your arrow direction. For this one, equal to this one. That means this in tension. And tension is positive. Let's do at joint E. In members EB, we don't have force, and ED is horizontal. We have vertical force of 6 kilonewton. That means this 6 kilonewton going down. In member EC, at joint E, we're going to have 6 kilonewton going up. And remember, we have gradient for this one. Gradient for member EE is 3 meter, 3 meter. Use the ratio method. Then we can find force in X direction by using ratio method. So here is 6. So we have 6 kilonewton. That's on joint E side. On joint C side, other way around. So this one to the right with 6 kilonewton in X, going down with 6 kilonewton in Y direction. Then we can find magnitude. 6 power of 2 plus 6 power of 2 square root. We're gonna have 8.49 kilonewton. If we take member EC from here, we know the arrow on E side into E, arrow on C side, joint C side into C. For this sign, we call it compression. And the value is negative. So this one is compression. So back at joint E, we know to the left 6 kilonewton, and also from member EC to the left 6 kilonewton. That's mean in equilibrium 6 plus 6 plus 6 12 kilonewton to the right on joint E side. That's mean on joint D side, other way around to the left is 12 kilonewton. If you check the arrow direction for ED, this one mean tension. Now we can find force in member DC. At point D, we know force 12 kilonewton to the right, and also we have force to the left with 12 kilonewton. That means no force in X direction. So check at joint D, 12 kilonewton to the right and 12 kilonewton to the left, and no more left for X force, and also no force in Y direction. Therefore, no force in DC from joint D. So value here is 0. Then check again at joint C, the value is 0 or not. So we know our CY is 6 kilonewton. So 6 kilonewton Y minus by 6 kilonewton from that one. So it's 0. 6 kilonewton on member BC to the left. Then minus with that 6 kilonewton. So 6 minus 6, 0. So no forces in X or Y. That means 0. That means our answer is correct. So we done on the real case. For the real case, we take out member BD and we're going to do virtual case, which is for the virtual case, we have to put back member